We should be live. Are we? For some reason it says upcoming, but then no, it does work. Want to make sure. Let's check that we're using the correct microphone. Yes, we're using one of the cameras. We have another one for doing. What was it? 3 colors. Right, for doing this. We have him behind me. This will recognize hands. The right one in red, yellow, left in yellow. So that's nice. We'll keep it running there for a bit. I'm having trouble with that window. It's oops. Yeah, it's I'm show. A CV2 is display the frame. Yeah, well, let's try using what's the purpose of this statement? Yeah, that's a good question. Purpose of the statement is display a frame in a standalone window, right? Yeah, so you can instead of using ChatGPT, assuming this should be more deterministic in its answers. So if we ask what, it will keep repeating the same thing again. CV2. OpenCV library. You can see if there's any other and says no. And normally we'll have a follow-up, not just hallucinating stuff, which is okay. What's the shortcut for? I know it has another option. I'm sure function will we already have that there. And you can accept by what control right what is a OpenCV. It's a library programming functionality aimed at real-time computer vision. It's a good answer. Is there no answer? No. And follow-up question. What is computer vision? Okay. Scientific field that deals with how computers can gain high-level understanding from digital images or videos. Great. Might just leave it there. What is a library? Okay. It's going places now. So that's that code there. Exiting. I can exit this video with a Q for whatever reason. This would not close it. Obviously a bit of a bug. If you hold on it, it stops moving as well. Yeah, if you minimize as well, there's all sorts of issues with that window. I have to keep it open on another screen for it to keep grabbing images. Yeah, the finger recognition, sometimes it's confusing it for the other hand when changing the color, and sometimes will not recognize the hand at all. Yeah, and sometimes it's surprisingly doing really well. So we'll leave it like that. We're actually using that for this Kaggle competition. I covered it yesterday and the day before as well. So I might just forgot to publish the link to the live stream. Just checking it on YouTube itself. Yeah, OBS is sometimes funny the way it works. Need to grab the link, put it up on Twitter as well. Yeah, we don't use Twitter, so it's a bit like with yeah, no, I shouldn't be saying it. I'll get cancelled. Close that. Want to publish it on. Someone is watching. Hello, hello. You can say hello. I'm still setting up. In the past, I was also setting up a Zoom room. If someone wants to go live together, those are much better streams when you actually interact with someone. I might just do it next. I'm just publishing a link to this stream on LinkedIn. We'll just take a second. Post that. Yeah, let's just start the. Where is that Zoom? So I just have to do all the things on another screen. So we're not just in the meantime while I'm doing it. We'll get back to parquet.com. A lot of these tools that I'm currently developing will eventually, depending on the license, if the license for the data is permitting, we will pop them onto parquet.com as a tool. So one option will be a tool that helps you learn sign language. You could turn your camera and sign to it like this. I don't know sign, but I could learn it myself. And it will give you a score of how well you are doing. And also, so the aim of this Kaggle competition that is running at the moment is that while someone is signing, there will be a sign to speech conversion happening real time. By the way, if you want to participate in that competition, it's currently running, and I'm happy to team up as well. Sorry, and I can't do two things at once. I'm just still setting up Zoom. Pop the link in the chat. We need to start virtual camera in OBS as well. We'll pop it into my. So that's the Zoom room. If anyone wants to join live, there's a link in the comments. Right, we're already almost 10 minutes into the stream and we haven't done anything. So this is the current code. As you see, the bot behind me is this code here. It was generated by ChatGPT. I lost the original prompts because I had to create another account in ChatGPT. We tried to use, just pop it in on the screen as well. Yeah, for some reason meant to save what you did on the OpenAI website, but obviously it's not there. That's actually was this a media pipe code. Interestingly enough, there's something wrong with the chat. Just start a new one. I mean, you could just pop the whole text into it. Yeah, sometimes it will truncate. This time it's okay. It will actually explain. Ooh. Right, yeah, it actually explains the text. The reason I opened a new ChatGPT account is because I actually want to use it in Edge, Microsoft Edge, the browser. That's because it has a really good text-to-speech tool inbuilt.
The code you provided is an example of how to use the media pipe library in combination with OpenCV to perform holistic and hand detection in real-time video. Let's go through the code and explain each part. Importing the necessary libraries. Python. Copy code. Imports. Here, we import the OpenCV library as CV2 and the media pipe library as MP. Initializing media pipe holistic model and hand tracking. Python. Copy code. MP underscore holistic equals MP.solutions.holistic holistic equals MP underscore holistic holistic. These lines initialize the media pipe holistic and hand tracking models. The holistic class is used for detecting facial landmarks and body pose estimation, while the hands class is used for hand detection and tracking. Initializing video capture. Python. Copy code. Cap equals CV2.video capture 1. Here, we initialize the video capture.
Yeah, by the way, I have like the two cameras running, so it's not on the, unfortunately I couldn't get it to run on the same camera because, well, yeah, because it's occupied.
Capture object cap to capture video from the default camera, index 1. You can change the index to use a different camera if available. Processing video frames in a loop. Python. Inside the loop, we read frames from the video capture object cap using cap.read. The frames are converted to RGB format using CV2.cvt color. Then, the media pipe holistic model and hand tracking model are used to process the RGB frames and obtain the detection results. Drawing face landmarks on the frame. Python. Face landmarks are detected. Results underscore holistic dot face underscore landmarks. The code extracts the face landmarks and iterates over them to draw circles on the frame at the corresponding x, y positions. These circles represent the detected face landmarks. Drawing hand landmarks on the frame. Python. Python. Copy code.
Yes, originally we had them confusing the colors of the two. It's hard to get rid of myself. It was getting mixed up with the two hands. It's still sometimes getting mixed up, but working much better. So we actually got ChatGPT to correct the code. And normally if you see in the code multiple things, I'll just comment this out and try the same thing again. That's when we use Copilot. So the, what's called? GitHub Copilot. So I haven't used it in this code, but yeah, I'll be using it later.
If hand landmarks are detected, results underscore hands dot multi underscore hand underscore landmarks. The code iterates over each detected hand and determines if it's the left or right hand based on the handedness information. For each hand, it.
All right, and for some reason, it's generating a lot. It segments the output into two, and then you have to press this button for some reason to continue generating. It's a bit odd. That's the way it is. Also, while it's generating, yeah, we have this clinical camel. I was actually using that to generate a lot of the text on my website. So recently, I think yesterday, I was generating this text which will explain what's on the website. Yeah, this tool was created a month ago or so, but it didn't have any text on the page. This is on barnchaos.com. Hopefully this text will help the search engines to pick on this tool and put it up in the search. So when you search for any of these terms, hopefully it will come up. And supposedly this LLM is it's open source. So it's on the algorithm is on Hugging Face. There's a paper as well, and it was optimized for clinical healthcare data. So I guess it's a bunch of papers. And interestingly enough, because it's open source as well, you can actually change parameters in here. Apparently temperature is how much it's making up stuff. So you can, and I don't know if higher or lower is so for example, we're interested in EEG down sampling. It's not how you spell down sampling, it's actually 2 words. That's okay. So it will generate this stuff. You can set the maximum number of tokens. I guess that will limit the length of the output. But then you can also change the temperature. Shall we go over this now? I don't know if anyway, let me know if you're interested in other things.
EEG downsampling refers to the process of reducing the sampling rate of an EEG signal. EEG signal.
Oops, I forgot
EEG down.
that this text to speech is actually driven by the mouse. So let's do one with 0.1 temperature, and then another one with the highest. And compare
EEG
between them
downsampling
quickly.
refers to the process of reducing the sampling rate of an EEG signal. EEG signals are typically recorded at a high sampling rate, such as 250 Hz or higher, in order to capture the rapid fluctuations in brain activity. However, storing and analyzing such high-resolution data can be computationally demanding, so it is often necessary to downsample the data to reduce its size and make it more manageable. There are several methods for downsampling an EEG signal, including averaging. This involves taking the mean of a set of adjacent samples. For example, if the original sampling rate is 250 Hz and the downsample rate is 100 Hz, every other sample is averaged to produce a new sample at the downsample rate. Decimation. This involves discarding certain samples and interpolating between the remaining samples. For example, if the original sampling rate is 250 Hz and the downsample rate is 100 Hz, every fourth sample is discarded, resulting in a new sample at the downsample rate. Zero padding. This involves adding zeros to the end of the signal to pad it out to a larger size, then downsampling the resulting signal. This method is useful for preserving the frequency content of the signal, but can introduce aliasing if the downsample rate is not an exact factor of the original sampling rate. Upsampling. This is the reverse process of downsampling, where the downsampled signal is interpolated to produce a higher resolution signal. The choice of downsampling method depends on the specific application and the desired trade-off between data size and retaining important information in the signal.
So interesting enough, when we reduced the temperature, it gave us the same output. So I don't know what's up with that. We just pop it into Word. We won't be spending much time on this. For some reason it's sometimes forgetting spaces. So it's called Camel Model because it's based on the Llama, the original Facebook LLM, and this one was trained on medical articles, I guess. Just try. So we change the temperature. Let's try to regenerate. Seem to be generating the same thing again. And there's no stop generating button like OpenAI has. Well, it's obviously the same. Just clear everything. We're setting temperature to 0.1. Doesn't seem to actually work. And I forgot what we asked. EG downsampling. EG downsampling. Let's just try it again quickly. I think it will. Let's see if it generates something. Yes, it does.
EEG downsampling refers to the process of reducing the number of samples in an EEG signal. This is typically done to save storage space or to make the data easier to analyze. There are different methods for downsampling an EEG signal, including averaging. This involves taking the average of a certain number of consecutive samples. For example, if you average every fifth sample, you would discard every fifth sample and keep only the average value. Filtering. This involves using a low-pass filter to remove high-frequency components from the signal. The cutoff frequency of the filter determines which frequencies will be removed. Decimation. This involves reducing the sampling rate of the signal by a factor of n, where n is an integer. For example, if the original signal has a sampling rate of 1000 Hz and n equals 2, the downsampled signal will have a sampling rate of 500 Hz. It's important to note that downsampling can introduce some distortions to the signal, so it's important to choose an appropriate method and to use the appropriate downsampling parameters.
Right. Just copy this for a sec. This is the same EG downsampling with temperature of 0.1, temp equal 0.1, and the default I think is 0.7. Let's just try it once more. Apparently need to clear history for it actually to take effect. And when we do quickly the same prompt with temperature of 1, what seemed to be the text is different, but I can't see much difference in terms of making stuff up.
EEG, electroencephalogram. Downsampling refers to the process of reducing the number of samples in an EEG signal. This is often done to save space or to make the data easier to analyze or store. The process of downsampling involves discarding some of the samples in the signal while preserving the important features of the signal. This is typically done using a low-pass filter, which removes high-frequency components of the signal. There are different methods for downsampling an EEG signal, and the choice of method will depend on the specific needs of the application. In general, it is important to ensure that the downsampling preserves the important features of the signal while discarding any noise or artifacts that may be present. One common method for downsampling an EEG signal is to use a decimation filter, which discards a certain number of samples in the signal for each sample that is kept. For example, a 2:1 decimation filter would discard every other sample in the signal, resulting in a signal that is half the original length. Another method for downsampling an EEG signal is to use a sample rate converter, which adjusts the sampling rate of the signal to a lower rate. For example, if an EEG signal is recorded at a sampling rate of 500 Hz, it can be downsampled to 100 Hz by simply throwing away every fourth sample. There are many other methods for downsampling an EEG signal, such as using a low-pass filter to remove high-frequency components, or using a combination of filtering and decimation. The choice of method will depend on the specific needs of the application and the characteristics of the signal.
Yeah, I can't see any obvious differences when changing the temperature of the LLM. The text is different, but I think it will be different if you regenerated this thing anyway. So there's no obvious difference. So let's go back to our code. That's the code that is running behind me, the bot behind me. So we're drawing right and left hand markers in different colors.
If hand landmarks are detected, results _hands.multi_hand_landmarks, the code iterates over each detected hand and determines if it's the left or right hand based on the handedness information. For each hand, it iterates over the hand landmarks and draws circles on the frame at the corresponding x, y positions. Left hand landmarks are drawn in red, and right hand landmarks are drawn in yellow. Displaying the frame in a standalone window. Python. Copy code. CV2.im show, frame with holistic and hand detection, frame. This line displays the frame with the drawn landmarks in a standalone window. The window title is set to Frame with Holistic and Hand Detection. The loop continues until the user presses the Q key. When Q is pressed, the loop breaks and the program continues to release resources and close the window. Release. After the loop, the video capture resources are released using cap.release, and the OpenCV window is closed using cv2.destroyAllWindows. This ensures that all resources are properly released and the program terminates gracefully. I hope this
Gracefully is a nice word for a bot. Okay, so that's that. Now we tried some other code as part of this competition. It's still going, but then there was a similar competition running 2 months ago. It was even a lot of competitors. They got some prize money, which is great. You can still join the competition. The main difference, I won't go into the details. I'll just the main difference between the current competition and that one is that in this they're trying to detect the whole hand, not characters. Sorry, they're trying to detect whole word symbols, sign symbols, not just individual letters. So the current competition is for spelling stuff, and the previous competition was for whole word signs. The reason I'm looking at it is because the competition have ended. This is the leaderboard, and the solutions were published. So we wanna there's both the public leaderboard is.
This leaderboard is calculated with approximately 50% of the test data. The final results will be based on the other 50%, so the final standings may be different.
Right, so the public, which you could calculate your score throughout the competition, was on 50% of the data, and then the private calculated to approximately 50% of the test data. So I guess this is calculated with the whole data. So someone that scored second place in a public leaderboard then scored first place. But as you can see, the numbers getting very close, saturated. This is how many participants there were in each team. So supposedly the prize money goes to the winner of the private leaderboard. So we have this code, this one here. So just let's go over it, see if we can run it locally, maybe not.
It takes around 6-7 hours to train a model with single fold. So you should run this notebook 4 times for each seed equals 42, 43, 44, 45 to get all 4 seed weights of the model. Or you can just press save and run all to get the result of the fold 0 model. There are 2 issues with this notebook. Training time issue. The weird thing is that it takes around 3 hours in Collab TPU v2-8, which is supposed to be slower than Kaggle's TPU v3-8. If you know a lot about TF plus TPU frameworks, please let me know how to debug this issue. Training instability. I changed some minor configurations from the final solution. I changed epoch 400-300, clip value equals 1. Dash to none, label underscore smoothing equals 0 dash, label underscore smoothing equals 0.1 for more stable reproducibility, with slightly lower accuracy. Instability mainly caused by high lambda value of the AWP, 0.2, it will cause NAND loss sometimes, around once out of 5 times. You can switch it to 0.1 or lower the learning rate and still can get fairly high accuracy. Also, if you have any idea related to this issue, please let me know. In 1.
Right, so we can ignore this issues for now. Shall we? So we can download code. It'll obviously be a Jupyter notebook. Just copy it into the right folder. We have it here. Right, and of course there were running it. I don't know if it makes much difference, but they were running it on Apple or Linux machine. Don't think. Do I need the add-ons and stuff? We'll see. See how we go. We might comment this out. Why MP arrays? Right, because we need to select an interpreter. Select kernel. Right, so we do need to install TensorFlow add-ons as DFA and TensorFlow mix precision. With this, explain what's the purpose of this import statement. Import TensorFlow libraries. Was another option to the answer. I'm just trying to learn how to. Oop. No, it's same. Just changing or removing that underscore there. Need a new chat. Just make sure. Let's compare this problem importance of flow. Import missing imports. Question. The import statement is not recognized by Python, but it's recognized by the Kaggle notebook. What? But I want to run it. Okay, it's not installed in the environment. Yeah, it's sometimes. Oops. I was forgetting how to control right arrow. How to install TensorFlow. The environment, pip install. TensorFlow add-ons. Okay. We need to be in this folder. Here. Scripts. It is scripts. Yeah. Yep. So that's where we how to install. Okay. Let's check if we have it first. No. installing. Successfully installed. So this should go sometime. Should go away. Yep. It takes about like 5 seconds or so. And we have another TensorFlow. Not the result. So let's both ask. It's obviously providing different answers. A question. Yes, result. I think this because TensorFlow is not installed. Yes. To install mix between library and the environment. So should just give the an answer. How about an answer? I think. What say? I think. By running the following command in the terminal, pip install. Right. Yeah, it keeps giving random stuff sometimes. And this is wrong.
If you're encountering the error message import tensorflow.keras.mixed_precision could not be resolved in your Python code, it means that the Pylons language server, which is responsible for code analysis and suggestions in some integrated development environments, IDEs, is unable to locate and import the tensorflow.keras.mixed_precision module. This issue can typically be resolved by following these steps. Ensure that you have TensorFlow version 2.1 or higher installed. The tensorflow.keras.mixed_precision module is available starting from TensorFlow 2.1. Verify that you have the correct import statement in your code. The correct import statement should be Python. Copy code. From tensorflow.keras.mixed_precision import experimental as mixed_precision. Make sure that your IDE
Obviously. Yeah.
IDE or editor is using the correct Python interpreter and that it is pointing to the installation of TensorFlow where the tensorflow.keras.mixed_precision module is present. If you are using a virtual environment, activate the environment in your terminal. Restart your IDE or editor. Sometimes, IDEs can encounter issues with resolving imports if they haven't been restarted after installing or updating packages. If the error persists, you can try using a different IDE or editor to see if the import resolves successfully.
No, so this should be installed already. I'll just save this quickly. Start it again. This should be DF. Let's try this. Comment it out because it doesn't work. How about I just do it? Oh, that's the same. Getting an error. Yeah, let's see. Sure, already tried this. Let's try ChatGPT again. Yes. Why it keeps telling me installing it from
It
people?
is a part of the TensorFlow library itself and can be accessed directly. To use mixed precision training with TensorFlow, you need to have TensorFlow version 2.1 or higher installed. The tf.keras.mixed_precision module is included in the TensorFlow library, so there is no need to install it separately. You can import and use the tf.keras.mixed_precision module in your code with the following import statement.
Yeah, that's statement. I'm still getting. Make sure TensorFlow is upgraded. Let's do that. Requirement already satisfied.
Once you have the appropriate version of TensorFlow installed, you should be able to import and use the tf.keras.mixed_precision module without any issues.
Oh, come on.
This import statement should work for TensorFlow versions 2.4 and above. If you're using an older version of TensorFlow, please let me know, and I can provide the appropriate import statement for that version. Make sure you have the latest version of TensorFlow installed. You can upgrade TensorFlow using the following command. After updating TensorFlow and using the correct import statement, the error should be resolved, and you should be able to use the tf.keras.mixed_precision module in your code successfully.
Ba, 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 ba. Don't need that. Let's do the Jupyter console. It's another problem. The warning, is it?
The warning message you're seeing indicates that you're using the tqdm library in a notebook environment, and it suggests using tqdm.tqdm instead of tqdm.autonotebook.tqdm to force console mode. To address this warning, you can modify your code and replace any occurrences of tqdm.autonotebook.tqdm with tqdm.tqdm. Here's an example.
What? Okay, where is it?
By making this change, the warning should no longer appear, and you can continue using tqdm in your notebook environment.
Check if we have this. Probably not. Not found. That was quick. Oops. What do? Severa was installed. Version 1.0.4. The error didn't go away. Probably needs a restart. Right. So warning. The endless modules.
The error message, ModuleNotFoundError, no module named tf_utils.schedules, indicates that the module tf_utils.schedules cannot be found in your Python environment. If you are trying to import the tf_utils.schedules module, it seems that it is not a standard module provided by TensorFlow or any other widely used library. Please ensure that you have the correct module name and that it is installed in your environment. If you have obtained the tf_utils module from a specific source or library, make sure you have installed it correctly. If you are working with a custom module or package named tf_utils that includes a schedules module, ensure that the module is present in the appropriate directory structure. Double check that the module file exists in a subdirectory named schedules inside the tf_utils package. If you are working with a third-party library or module named tf_utils.schedules, please check the documentation or the source from where you obtained it for instructions on installation and usage. If you still encounter difficulties, please provide more information about.
No, we don't have a TPU. We want to run it on the GPU, but it's okay. CPU should be okay as well. That was truncated. Right, well, we don't have the data. That would be a problem, isn't it? Just try to run it on the online. Right, to run it, you have to actually accept the rules for the competition, even though it's already ended. Let's say it takes 3 hours to run. That's not fun. Draft session starting. Warnings. I'm meant to be running it in the virtual environment or something. Should print the TensorFlow version, Python version. I think for whatever reason they're always using non-updated, not recent version. There's a bunch of warnings. Yeah. Right. I think that's when the code was generated in April 12, and the default Python version at the time was 3.8. Connecting to TPU. There's 8 TPU cores. So it's a transformer processing unit, is it? Okay, train file names. So get access to the data, which we don't have locally. Train data frame. The good thing about this code is I don't know if it's already. Yeah, it's this bit. This is really nice. So it's actually showing the hands location of each finger is very nice. Reflect. The nice interface for playing stuff. Increase speed, decrease speed, loop. Alright, so we see transitions between different letters, the sign language, which is nice. Animate frame, filter down, left, so it's left hand, and that will be right hand. A bit slower. That's handy. That's supposedly the data that we have as part of the previous connotation and this one as well. Animate frames, filter. What are those? Looks like the hand. And what's this? Is this the face? No. Looks like an upside down face. Like eyes, nose, and mouth. I'm trying to lip read as well. Don't get it. What landmarks? Okay. Can we do it for our own data? Playing is HTML animation. This animation is nice. It's actually the makes it much clearer. Did someone adapt this code for the current competition? Ba, 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 ba. There's no comments whatsoever. It's hard to determine what this code does. Pop that into ChatGPT. Let's also try bu- 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 Finish generating.
The code you provided defines two functions, seed_everything and get_strategy. It appears that you are using these functions to set random number generator seeds and configure the TensorFlow strategy for distributed training. The seed_everything function sets the random number generator seeds for Python's built-in random, numpy's np.random, and TensorFlow's tf.random. This ensures reproducibility by fixing the initial state of these random number generators. The provided seed parameter allows you to specify a particular seed value, default is 42. The get_strategy function determines the TensorFlow distribution strategy based on the specified device. If the device contains the string TPU, it connects to a TPU cluster resolver and returns a tf.distribute.tpu strategy object. If the device is GPU or CPU, it checks the number of available GPUs and selects either tf.distribute.mirrored strategy for multi-GPU training or tf.distribute.get_strategy for single GPU or CPU training. It also sets the is_TPU flag based on whether a TPU is being used. The function then returns the strategy, the number of replicas, and the TPU flag. Finally, the last line of code calls get_strategy with the default value of device and assigns the return values to the variable strategy, n_replicas, and is_TPU. Please note that this code assumes that the required libraries, such as OS, random, NP, number_py, and TF, TensorFlow, are imported correctly. Also, ensure that you have the necessary dependencies installed to execute this code.
Well, first we don't have a TPU. Then to understand why you need to like a general description for the code. Probably not. It's fine because it will take the output from Kaggle, because you don't have TPU cores. They have a GPU, so I don't know if it can run. Getting stuck again. Let's just continue from scratch. It's easier. Take some of the concepts from the competition, but really um, uh, face detections don't recognize. To understand how Visual Studio Code yeah, kind of have to run them both in parallel, because one has the chat function, which is handy. Can we also display the hand landmarks? Display hand landmarks. It should be in the same. Many hands are detected. Tuples, sealed tuples until the input is exhausted. Yes, I assume we could just have the table or the you do it over here. No. Play a table of landmarks or hands alone. We don't need the face. No. Why? Yeah, obviously it's struggling. Uh, pa, 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 pa. If we pop this again into a ChatGPT, a new chat, just pop this code in for it to explain it again. Why I didn't ask to modify it. Alright, it actually understood that I'm trying to add the table landmarks, and hence you can modify the existing code. Let's run a new Python script. A video capture 1, that's correct, that's the camera that we're using. Brain. Yeah, so that's what does. It's putting the text. Is it on top of the image? Not sure. Let's just save it first. With table, a coordinates table. TensorFlow Lite delegate for CPU. What if I can delegate to a GPU? Where is the table? I don't see the. Ooh. So we have the numbers there. Don't see a table. Like this be scalable. 0, 1, 4, 5. So we have this 20 parameters. Only on one hand, we don't get it on the other. It's not really a table, but okay. What did it say?
In this modified code, the for loop iterating over the hand landmarks has been extended to include printing the landmarks as a table. The landmark index is displayed as text at the corresponding landmark coordinates using cv2.putText. The index is obtained using the enumerate function to provide a unique identifier for each landmark. This will display the index numbers near each. Regenerate response.
And finish generating. Table-like representation. That's only doing it for one of the hands. To do it for the other hand. So on one hand we have those numbers. We just leave it like that for a sec. Still need to open. We need to open the files, the parquet, parquet. What's the problem with that code? Well, can you run it? So say if I, what on earth? Leave it there. That's impossible to navigate. Precalculus with coordinates. We had that code there. No. Load data. Right, that's the data that we have as part of this competition. We like those videos, like the other competition had. So we have those, each of those parquet files is spelling out these phrases. Already mentioned it like several times before. We are not making much progress. A print, what's that? Run everything above this. Okay. Right, so we're taking the first. Right, I remember generating this code. The first column, displayed above the first parquet file. To know what's up with that. It's actually generating the numbers. So that's where we got so far. Those will be labeled. run everything. Doesn't take long to run. Let's check the train. So we have the JSON, the character to prediction index. We have the train landmarks. And we need the predictions of this. Train and train landmarks. And then in train CSV, we should how do we turn this into this nice video? Rows per frame, point landmarks. Reprocess. There's no comments whatsoever, which makes me think like that code was copied from somewhere. That's okay. Temporal crop, temporal mask, special mask. Yeah, I want to see the spelling of those. Pattern display, HTML. What? So can we do this? Let's start the new code. There's a lot of magic numbers. So what's generating this? What's it like temporary something? Pa. Don't understand data. Frame. So how many? What? A redraw group 0. How many groups? How many groups? Same. Pa, pa, pa. Right, so it has to stay. What is storing it is? No. Count data items, file names. Okay. Rows per frame, maximum length. They get all these magic numbers from. Because it is a leap of a face because you have pose, eye, hand. They ignore pose of nodes, point, landmark, channels, 6. So in this one we think only have the hands. I think it leaps probably. Face. 300 frames. Right hand, left hand. How do we do? We do have the whole shebang. Reprocessing. Why is it left lip, right lip? Left pause, right pause. Yes, there are two eyes. There's one set of lips, in theory. So how many rows do we have per frame? Is it? Right. So we have that many rows. Was it rows per frame? Number of classes. Number of nodes. What? Why did it suggest that if it doesn't actually exist? And the function, there's no explanation of what it does. Returns X. X is image resizing the image. Create. Oh, this does. Oh no, it does. Reprocess. Like a note of where this code was taken from. So there's only one. It can't be one frame. This thing should have. That's the parquet file. Yeah, we need a metadata. Number of rows, number of columns. So there's a whole face detection. Those the frames. They have the frame number. Oh, I'm so confused.
A class in the PyArrow library that represents the metadata of a parquet file. It contains information about the schema, column names, data types, and other properties of the parquet file. Parquet is a columnar storage file format that is commonly used for big data processing and analytics. It offers efficient compression and encoding techniques, which make it suitable for handling large datasets. The PyArrow_parquet.FileMetadata class provides methods and attributes to access and manipulate the metadata of a parquet file. Some common operations you can perform with this class include accessing the schema. You can retrieve the schema of the parquet file using the schema attribute of the file metadata object. The schema represents the structure of the data stored in the file, including column names, data types, and nested structures. Retrieving column names and data types, the file metadata object provides methods like number underscore columns and column underscore name to retrieve the number of
We want to bring this schema. It should tell us. We don't need the third one there, but leave it there for now. No, what?
Class provides methods and attributes to access and manipulate the metadata of a Parquet file. Some common operations you can perform with this class include accessing the schema. You can retrieve the schema of the Parquet file using the schema attribute of the file metadata object. The schema represents the structure of the data stored in the file, including column names, data types, and nested structures. Retrieving column names and data types, the file metadata object provides methods like number underscore columns and column underscore name to retrieve the number of columns in the file and the name of a specific column, respectively. You can also use the column underscore schema method to obtain the schema information for a specific column.
Is that the label names?
Manipulating metadata properties, the file metadata object allows you to modify certain metadata properties of the Parquet file. For example, you can update the file schema, add or remove columns, or modify column properties like data type or compression. It's worth noting that PyArrow underscore parquet.FileMetadata is an internal class in the PyArrow library, and the underscore prefix indicates that it is intended for internal use. Directly accessing this class may not be necessary for typical Parquet file operations. Instead, you can use the higher-level APIs provided by PyArrow, such as pyarrow.parquet.read_metadata and pyarrow.parquet.write_metadata, to read and write Parquet file metadata.
Just put this in. It should tell us.
The output you provided is the representation of a pyarrow underscore parquet.FileMetadata object. It shows the metadata information of a Parquet file. Here's a breakdown of the information provided. Created underscore by specifies the tool or library that was used to create the Parquet file. In this case, it indicates that the file was created by the Parquet CP PyArrow version 11.0.0. Number underscore columns indicates the number of columns in the Parquet file. In your example, there are 1,631 columns. Number underscore rows specifies the number of rows in the Parquet file. In your example, there are 162,699 rows. Number underscore row underscore groups represents the number of row groups in the Parquet file. A row group is a logical division of the data in a Parquet file containing a subset of the rows. Format underscore version indicates the version of the Parquet format used in the file. In your example, it is version 2.6. Serialized underscore size specifies the size of the serialized metadata in bytes. In your example, the serialized size is 770,819 bytes. These details provide insights into the structure and characteristics of the Parquet file, such as the number of columns, rows, and row groups, as well as the Parquet format version and the library used to create the file. Regenerate response. The output you provided is the representation of a pyarrow underscore parquet.parquet schema object. It represents the schema of the Parquet file, specifying the structure and data types of the columns. Here's a breakdown of the information provided. The schema consists of a group field with field underscore ID equals -1, which indicates the root group.
Back in a sec.
The output you provided is the representation of a PyArrow underscore parquet.parquet schema object. It represents the schema of the parquet file, specifying the structure and data types of the columns. Here's a breakdown of the information provided. The schema consists of a group field with field underscore ID equals -1, which indicates the root group. Inside the root group, there are several optional fields representing different columns of the parquet file. Each field has a field underscore ID of -1, indicating that the field does not have an explicit field ID. Some example fields mentioned in your output are frame, an optional field of type int32, representing the frame column with a bit width of 16 and signed integer values. X underscore face underscore 0. Optional fields of type float, representing the x-coordinate values of different facial landmarks. Optional fields of type float, representing the y-coordinate values of different facial landmarks. Optional fields of type float, representing the y-coordinate values of different right-hand landmarks. This representation of the parquet schema provides information about the column names, data types, and hierarchy of the fields present in the parquet file.
Right, so I don't need any of that to return frame optional interface. We need the frame number. We only want to retrieve the hand. So over the frame, we want to return this one. Let's go. Name frame path frame. Just 16. What? How do you search this file over there? already have the parquet file. And comment this out. Let's comment that out as well. Metadata. Frame call exists. Does exist. Frames exist. Do not exist. Okay, that's great.
In the code above, you need to replace path_to_parquet_file with the actual path to your parquet file. The code reads the metadata of the parquet file using pq.parquet_file and retrieves the schema using metadata.schema. It then checks if the frame column exists in the schema by checking if frame is present in the list of column name schema.names. Free research preview.
If print frame column. Why is it going for schema? Don't get it. Why is it assuming 0, 0? Don't get it. That's correct. This is more like it. What? It's an error in the code. Okay.
Seems there was an error in the code. To access a specific column in PyArrow, you can use the read method of the parquet file object with the columns parameter. Here's an updated version of the code.
Read column. Okay, those are the frames.
In the code above, replace path_to_parquet_file with the actual path to your parquet file. The read method is used with the columns parameter set to frame to read only the frame column from the parquet file. The resulting column is then converted to a pandas data frame using the to_pandas method. Make sure to have the PyArrow and pandas libraries installed, pip install PyArrow pandas, before running this code. Regenerate response.
I should have that one. So I have the frames. Frame number. Means some frames are missing or there's more. I might just take this offline and we will continue probably next no, probably the week after, taking a bit of a break, but there will be more videos uploaded. We'll see you next time.